At 10:47 in the morning, Titan sent a message from more than 3,000 meters beneath the North Atlantic. It had dropped 2 weights. The message sounded routine. The surface team replied. Titan did not. Within moments, both communication and tracking were gone. But the first sign of this disaster may not have appeared on that final dive. It may have arrived 11 months earlier, as a violent bang heard inside the submersible and by people waiting at the surface. Titan returned to the ocean anyway. So why was a vessel carrying 5 people allowed to descend when nobody had established how many dives its pressure hull could safely survive? For 4 days in June 2023, the world watched a rescue operation unfold above the wreck of Titanic. Ships crossed the search area. Aircraft listened for underwater sounds. News broadcasts displayed estimates of Titan's remaining oxygen. 5 people were inside. OceanGate Chief Executive Stockton Rush, British businessman Hamish Harding, Pakistani businessman Shahzada Dawood and his son Suleiman, and French Titanic expert Paul-Henri Nargeolet. The public story was a race against time. Then, on June 22nd, a remotely operated vehicle reached the seafloor. It found pieces of Titan roughly 330 meters from Titanic's bow. The pressure vessel had failed when communication disappeared. The 5 occupants had not spent 4 days waiting in darkness for the air to run out. The oxygen countdown had never described what was happening inside Titan. And with that discovery, the central mystery changed. The question was no longer where the submersible had gone. It was how a machine with an unknown structural life had been allowed to return repeatedly to one of the most hostile environments on Earth. The answer began with an idea that was genuinely ambitious. Titanic rests approximately 3,840 meters below the surface of the North Atlantic. At that depth, the water exerts more than 5,500 pounds of pressure on every square inch of a vessel's exterior. There is no light, there is no rapid rescue, and there is almost no tolerance for structural uncertainty. Titan was a submersible, not a submarine. It depended on a support ship to carry or tow it, launch it, track it, and bring it back. OceanGate wanted Titan to make deep ocean exploration more accessible. Paying participants would help finance expeditions, while researchers and Titanic specialists gained access to the wreck site. To carry 5 people, Titan needed more internal space than the small metal spheres commonly used in extreme depth vehicles. OceanGate chose a different shape and a different material. Titan's main pressure vessel used a long carbon fiber composite cylinder connected to titanium rings and closed by titanium domes. Carbon fiber can be remarkably strong and light, but surviving pressure from the outside is a different problem from containing pressure on the inside. Every descent squeezed Titan's cylinder. Every ascent released that load. Each journey to Titanic was another full pressure cycle, and a composite structure is made from many layers. Damage can develop between those layers without leaving an obvious mark on the exterior. None of this made the concept automatically impossible. Experimental engineering is how new technology is created, but the more unusual the design, the more evidence it demands. How strong is the full-size structure? How does it fail? How many pressure cycles can it survive? And can growing damage be detected early enough to protect the people inside? According to the final investigation, OceanGate never established those answers for Titan's final pressure vessel. Before that vessel was built, however, there had already been warnings that the process was moving too quickly. Crewed submersibles can undergo independent review by classification societies. Specialists examine the design, inspect construction, witness testing, and continue surveying the vessel during its operating life. Classification cannot guarantee that an accident will never happen. but it forces a company's calculations and assumptions to face outside scrutiny. OceanGate initially planned to have Titan classified. In 2018, it abandoned that effort. Former personnel later told investigators that the process would take too long while the company was under financial pressure. That same year, specialists associated with the Marine Technology Society's submersible community drafted a letter expressing concern over OceanGate's approach and its planned Titanic expeditions. The Society did not formally issue the letter, but the National Transportation Safety Board reported that Stockton Rush received it. The warning was not that every new idea must be rejected. It was that departing from established safeguards without adequate verification could end in catastrophe. The sharper warnings came from inside OceanGate itself. In January 2018, the company's Director of Marine Operations submitted a quality control report concerning Titan's first carbon fiber pressure vessel. Sections removed during manufacturing showed signs of porosity and delamination, places where the composite layers were not behaving as one solid structure. In a recorded conversation, Rush acknowledged that the director had fundamental concerns about Titan's safety. 4 days later, the director's employment was terminated. OceanGate continued testing the first hull. People inside the vehicle heard cracking sounds during dives. Then, in 2019, an employee discovered a hairline fracture in the cylinder. Examination traced it to an internal delamination. OceanGate's Director of Engineering refused to approve the planned Titanic expedition. He was terminated shortly afterward. The expedition was canceled. The first pressure vessel was condemned. OceanGate now had direct evidence that its carbon fiber hull could develop hidden damage. The company decided to build a second one. The crucial question was whether it would also build a stronger process for proving that the new hull was safe. OceanGate changed the material preparation and manufacturing process for Titan's replacement pressure vessel. Before constructing the full-size cylinder, the company tested smaller models. One developed wrinkles in its composite structure and imploded at approximately 2,800 meters. A second test was stopped at around 2,500 meters when the data indicated that failure was approaching. Both were shallower than Titanic. OceanGate believed it understood why those models had performed badly. The manufacturing approach was adjusted, and the final full-scale cylinder was produced between late 2020 and early 2021, but one decisive test was never performed. OceanGate did not build and destroy a representative co-bonded pressure vessel made with the same final process. Without that test, the company could not compare its theoretical model with the actual failure behavior of the structure that would carry people. The calculations assumed ideal geometry and ideal fiber alignment. The real cylinder was not ideal. After the disaster, investigators examined recovered material and manufacturing offcuts. They found porosity between layers, voids in adhesive, wrinkles and waviness in the carbon fiber, and a pre-existing area where bonded material had already separated. OceanGate had also failed to establish a verified service life. There was no proven number of deep pressure cycles after which Titan's hull had to be retired. Instead, the company relied heavily on a real-time monitoring system. Acoustic sensors listened for activity inside the cylinder. Strain gauges measured how the structure changed as pressure increased. OceanGate believed this system could warn the crew before the hull became unsafe. The idea was compelling. The vessel would listen to itself, but the system had not been proven capable of identifying the progression toward failure in Titan's final hull. It could collect signals. The harder problem was knowing what those signals meant. For a time, that distinction was easy to overlook because Titan began reaching Titanic. During the 2021 and 2022 expeditions, Titan successfully reached the wreck 13 times. Each return appeared to validate the design. The vessel descended. It reached Titanic. It came back. The monitoring system had not ordered the crew to abort. To clients, investors, and the public, Titan seemed to be proving that the critics had been too cautious. But every successful dive contained a dangerous illusion. Surviving one pressure cycle does not reveal how much strength remains for the next. Microscopic damage can grow between composite layers, while the outside still appears unchanged. Success is not the same as a safety margin. On July 15, 2022, Titan completed another visit to Titanic. It was designated Dive 80. During the ascent, a violent bang was heard inside the submersible. The sound was also heard by crew in a small boat at the surface. OceanGate personnel were told that the hull had shifted in its metal cradle. The monitoring data was reviewed. Operations continued. Titan performed 3 more dives during that expedition. After the disaster, investigators returned to the data recorded at the moment of the bang. The acoustic sensors had detected a burst of activity. Some strain readings changed suddenly, and when strain was compared against depth, Titan's behavior after Dive 80 was no longer the same as before. Earlier readings had followed a largely linear pattern. On later dives, some readings became non-linear near the surface. The NTSB concluded that the bang was likely associated with one or more delaminations forming between bonded layers of the pressure vessel. Titan had not simply made an unexplained noise. The hull had probably announced that it was damaged. Investigators concluded that the submersible should have been removed from service after Dive 80. Instead, OceanGate interpreted the event in a way that allowed operations to continue. Titan had survived the bang. That survival was treated as reassurance. In reality, it may have been the last clear warning the company would receive. After the 2022 expedition, Titan remained outside through the Canadian winter. Investigators could not prove that freezing conditions damaged the hull, but they considered the possibility that water entering an existing separation could freeze and expand. The next season introduced another change. Previously, Titan had been carried aboard its support vessel. For the 2023 expedition, the submersible and its launch platform were towed behind Polar Prince for approximately 2,900 miles across the open ocean. The journey exposed the vehicle to vibration, repeated impacts and bending forces that OceanGate had not adequately studied. The NTSB concluded that Titan deteriorated further after Dive 82, although investigators could not determine the precise source of all later damage. By June 2023, Titan's pressure vessel had experienced repeated deep cycles, a probable delamination event, months of outdoor storage, and a long open ocean tow, but its remaining strength was still unknown. On June 16th, Polar Prince left St. John's with Titan in tow. 2 days later, the expedition arrived above Titanic. Early on June 18th, the 5 occupants entered Titan. The forward titanium dome was closed and bolted from the outside. At approximately 9 o'clock, the submersible began descending. This was Dive 88. It was also the first dive of the 2023 expedition to descend beyond 10 meters. There had been no progressive series of deep test dives that season. For more than an hour, communication with the surface appeared normal. Inside Titan, the light disappeared. The temperature fell, and with every meter, the pressure increased. At approximately 3,363 meters, the ocean was exerting thousands of pounds on every square inch of the hull. At 10:47, Titan reported that it had dropped 2 weights. Dropping weight during the descent could be a routine way to control speed. The support team acknowledged the message. Titan never responded. Investigators later concluded that the carbon fiber cylinder suffered a local buckling failure. Existing delaminations and additional internal damage had weakened the structure until it could no longer resist the surrounding water. The pressure vessel fragmented. The failure was catastrophic. There is no evidence that the occupants spent hours waiting for rescue or listening to the oxygen run out. The submersible had already been destroyed when communication stopped. On the surface, however, nobody yet knew that. And because Titan was not continuously tracked by a system that could immediately confirm the implosion, the world entered a 4-day search for a vessel that no longer existed. On June 22nd, remotely operated vehicles found Titan's wreckage near Titanic. The titanium domes were separated from the pressure vessel. Pieces of the carbon fiber cylinder had fragmented and peeled apart across the seafloor. The wreckage allowed investigators to see what external inspections during operation had not revealed. The composite contained manufacturing defects and internal damage. The monitoring system had recorded important changes, but OceanGate's interpretation had not turned those signals into a decision to stop. The final reports did not identify one reckless movement made during the last few seconds. They described a chain that extended across years, an unusual design without adequate full-scale destructive validation. No verified safe cycle life. Independent classification abandoned. Internal and industry concerns that did not stop the program. A first hull that cracked. Subscale models that failed before reaching Titanic depth. A loud bang followed by changed monitoring data, and continued operation of a pressure vessel that investigators concluded was already damaged. The NTSB determined that the probable cause was OceanGate's inadequate engineering process, which failed to establish Titan's actual strength and durability. Contributing factors included insufficient regulatory guidance and OceanGate's flawed interpretation of its monitoring system. The investigations also exposed gaps in oversight. Titan was not registered under a flag state, was not inspected by the United States Coast Guard, and was not under a classification society. Those gaps mattered, but they did not remove OceanGate's responsibility to demonstrate that its vessel was safe. Other crewed submersibles have reached similar or greater depths using independent review and established engineering practices. Titan was not lost because visiting Titanic was impossible. It was lost because the evidence needed to justify this particular vessel and its continued operation was never established. The United States Coast Guard called the disaster preventable. The phrase, "they were warned," must be used carefully. It does not mean that every person who entered Titan had read every engineering report or understood the condition of the pressure vessel. It does not mean that anyone knew the exact dive on which the hull would fail. And it does not mean that one letter or one employee predicted the precise event. The warnings were cumulative. OceanGate was warned that an experimental design required independent scrutiny. Employees raised concerns about construction, testing, and safety. The first hull developed a fracture linked to delamination. Smaller test vessels failed or approached failure above Titanic depth. The final hull had no verified service life. And after Dive 80, Titan produced a violent sound and monitoring changes that investigators later identified as probable evidence of damage. No single warning revealed the exact amount of strength remaining. Together, they revealed something just as important. OceanGate did not know. Titan is often remembered through its strangest details: the game controller, the improvised interior, the expensive journey to a famous wreck. But none of those details explains the implosion by itself. The deeper failure was a process that repeatedly treated uncertainty as permission to continue. Innovation was not the enemy. Unverified confidence was. Titan was built to carry people into a world where the pressure leaves almost no room for error. At that depth, a machine cannot survive on belief. It survives on evidence.